In this lab project, we're going to work with the L43, L45 series of compact logic, 1767, 68. We're specifically going to work with the communication modules, module 4, the L43 and the L45. That was kind of a unique compact logics platform that kind of bridged between RSLogix and Studio. It was its own unique hardware. You could use this 1769 I/O modules, but the L43 and L45 had two backplanes. It had an active, semi-active, and it had a passive backplane. So as a matter of fact, there's one sitting right here, and to that side of the processor you have the ENBT and the Circos card, which are unique to that platform. And then on this side, you have the regular 1769 I/O modules. So let's look at the COM modules for the L43. Welcome to the lab titled Adding Communication Modules to a 1768 Backplane. That's the passive backplane for the L40 series, and this is also going to include remote I/O. Continuing on with our changing the processor type, we added some I/O modules. We actually deleted the I/O modules that we had with the L35E, and of course the module defined tags didn't disappear. The class of objects that you see over here on the left. And then we added in the actual I/O modules with a slightly different part number for the DC and for the analog. And then the next step, and by the way, we did go through and kind of re-alias some of the tags just to show you how to do it. But remember that there were a number of tags that didn't get edited, that we didn't edit the tags to re-alias them to the new I/O addresses, and we're not going to do that. That's not part of this lab, so I'll just leave that one up that was finished. And I'll scroll back down here so we can see our module defined tags and our I/O configuration. So the next thing that we do is we add some communication modules to the 1768 backplane. And the 1768 backplane, which is right here, 1768 bus over on your left, the 69, this is an active backplane. This is a passive backplane. So this backplane is well described in the lectures series for the Complete PLC Learn series. If you have the lecture disc or if you are watching them on YouTube. And by the way, we primarily put them on YouTube for everyone to have access. Many people still buy the disc, we assume, so they can have a hard copy, so it's more convenient. So there is lectures on there that cover the active backplane, like the 1769 bus. Now the 1769 bus with some of these newer modules is an improved active backplane, but it's still active nonetheless. And then the 1768 bus is a passive backplane. Now those are strange words maybe, but if you watch those lectures in the lecture series on active backplanes, you'll understand. Basically a passive backplane, no one really controls anyone. The processor basically informs the modules on the passive backplane what their configuration is, and then each of the modules on a passive backplane has its own microprocessor, its own firmware, its own RAM, and it behaves as a unique entity data-wise. And there's even some 1756 modules that you can actually put logic in. But that's a story for another day, another lab project. We're not doing that today. Nonetheless, 1768 backplane, so we want to add some communication modules. The first one we want to add, of course, is Ethernet. You never want to be without Ethernet. So I'm going to right click, new module, and you can see the only modules that are available to put on the 1768 backplane are what kind. If you look down through there, ControlNet, Ethernet, Circos, or generic 1768. Now, of course, generic, I wouldn't even consider that as a module. I'm sure that there's some out there sold by, I'm drawing a blank on the name of some of the companies, but there's one company out there that makes quite a few aftermarket modules for all of the Allen Bradley processor platforms. ProSoft, that's who I was trying to think of, ProSoft. If you go there and look at their ProSoft's website, and you'll recognize the modules by their bulletin number. So there's 1771. I don't think they have any for that older, real old stuff. And then 1747, 1768, which you're looking at right here. And let's see, what else? Probably 1761, maybe. But anyway, so we're going to pick the ENBT. The eWeb basically is like an ENBT, except it has reduced functionality in one area but increased in another. It is actually enhanced for creating a web page to put on the module. Now, most of these modules have web pages in a sense. In other words, you can go there by typing in the Ethernet address, and it will open the web page for that module. And you can see whatever you want to know about that module right on that web page. Maybe we'll do that if we get a chance. But ENBT, double click. The major rev level. You know, I don't know what we have, but we'll just see if that, we'll just say 4 and assume that we have the best. Okay, so I'm going to call this by ENBT. And we could go to RSLogix and check. And I'm going to give it an address of, well, 192, 168, 1.98. I realize that I don't remember what is used and unused in our Ethernet scheme, so I'll just put that in. If we have to change it later, we change it later. Now, in the lab, I had you put in, I think, 99, but I think I already have 99 assigned to something else, either with the L35E or with my the NIC on my laptop. So it has to be in the same sub network. Our sub network is 192.168.1, and then our network would be the last octet, 0 through 255. And of course, you don't use 0, and you shouldn't use 255. So anywhere in between there. And I'm going to disable the keying to take the rev level right out of the mix. Click OK. Now you see we have an ENBT and of course Ethernet, because the ENBT is plugged into the backplane, and then coming off the front or bottom of the Ethernet card is a RJ45 to plug in an Ethernet cable. Now, just for grins, I think we'll go to RSLogix. We'll open up RSLogix, and first I'm going to show you, I have two drivers here. This is the DF1 RS232 driver, and this is the Ethernet driver. This is the one we've been using, so I'm going to expand this. And there you see the backplane. Now remember, this is the L45. Okay. RS232 can't be plugged into both the L45 and the L35E simultaneously. That would take some adapters and defeat the purpose. And then I can expand this out. There's our Ethernet card, and of course there's nothing plugged into it. It sees itself. So see NBT, NBT. So this is a graphic placeholder to show what is on that Ethernet. But this is a graphic placeholder, not an actuality. This is the actuality right here, right above it. This is the NBT, that's not. Okay, then we can expand. Now this is a module that we haven't added yet, but in RS Networks you can see them. Okay, and this is a placeholder for the MO4SC. Now, if I were to turn on the drive that's connected to that Circos module through the Circos fiber optic network, it would probably show up. Okay, I just went and plugged in the drive. When I say plugged in the drive, what I mean is the fiber optic cable was already connected, and all of the motor cables, encoder, all that were all connected on the drive, but I had the drive unplugged because of the noise it makes. And I don't know if you can hear the noise in the background, but the fan on the Ultra 3000 drive makes enough noise that it is probably showing up in the recording. So I just plugged it in long enough for you to see that now there's a plus sign on the Circos interface. Before, we had MO4SE and then it dropped down and showed Circos, but it did not show a plus sign. If we expand that, and again, of course, it shows a graphic placeholder that the MO4SE is on the Circos network, which it is right here. That's the actuality. That's a graphic placeholder. Then here's our Ultra 3000 230 volt AC Circos drive, 10 amp, 30 amp, blah blah blah. Okay, so get that to show up again. Yeah, 2 kW. So it's not the smallest Ultra 3000. It's just one that I bought online used, along with an MPO motor and a few other, a linear actuator and some other things, just so I could create motion labs. So I'm going to pause and unplug the drive to get rid of that noise. And of course, this is typical of RSLogix. If RSLogix through RSWho sees something and has an EDS file to support it, it brings up the image. But it remembers what was there. It doesn't forget unless you remove it. So I could right-click on this and remove it, and it would basically stay gone. But we'll leave it there. It's a pleasant memory. But it's gone. The noise is gone from the fan, and the drive is gone as well. But I just wanted to take you a quick trip through this drive, or the DF1 driver again. Now, here's what we want to do using this driver. I'm going to go into the ENBT that we added. Now remember, it doesn't have to be added in the project to show up in RSLogix. And I want to go to Module Configuration, Port Configuration, and I want to change this to 192, 168, 1. I think I used 98. Okay, and we can tighten up the subnet mask. It really doesn't matter. But since I basically told you this was the subnet mask we had, we'll stick to that. Okay, I'm going to hit apply. And okay. Now, if I've done this all correct, now remember, you could see everything here. Okay. This is expanded all the way out. And remember, we also have the compact bus. So this is also part of the L45. So we can, go right on down to our digital modules. This is an RSLogix. Keep this in mind. RSWho is a little app that you can open in RSLogix that browses a driver. It goes out there, and whatever it finds, if it has an EDS file that has been registered in RSLogix for this particular identification. You say identification, what does that mean? Right click, device properties. That's the identification right there, the ID. Now, you can retrieve this information with a message instruction. You can do a message read instruction in Logic that goes and reads the identification from anything, anywhere within the electronic reach of the processor. But here's the idea right here. Device name is not available, but it's vendor AB, product type 7, which would probably be discrete I/O, product code 67. So we'll say that vendor AB, since they basically created Ethernet IP device net control net and then gave it over to ODVA, they're probably vendor number 1. So this actual information probably is vendor 1, product 7, code 67, revision 3.001. And it even has an EDS file name. So you could take this file name, go search on the internet and probably find it. Now, I don't know what the 3XX is. I don't know what the 2 X's are. But that is the ID. So in RSLinks, you can go pretty much look at everyone. Keep in mind, that's the EMBT, that's not. This is the Circos card, that's not. So if you right-click on one of these and go Device Properties, unable to establish communication with a selected device, probable causes. I'm not going to read down through them all, but that's because that isn't there. It's here. This is just a graphic placeholder to remind you from the Circos interface standpoint, these are the 2 items that are on Circos right now. Now, these 2 are connected with a fiber optic ring. In other words, 2 fiber optic cables that go from this device to this device. But we could add another drive in there because this is an MO4 SE. It'll support 4 drives. So we could take and run a fiber optic cable from this card to this drive, to another drive, to another drive, to another drive, another drive, and then back to this card and have a fiber optic ring with 5 devices on it. That's what it supports. So we're going to collapse this down to make some room. And then we're going to go to Ethernet. And on Ethernet, we have my computer, 100. And then we have this Ethernet to the L35E. So I can drill down, see I'm coming in through Ethernet, not through RS-232, to the backplane. There's the process. See, it's still got the program in it, or it still has the processor name conveyors, even though we may have another project name in there. It still remembers that the last time it was told who it was, its name was conveyors. And then, of course, there is no place to go outside of DF1, but it does show you that the compact logic processor sees channel 0. But these are both the same item. This is the actual, and this is just a graphic placeholder. I know you're probably getting tired of hearing that. So now we'll go with the local bus adapter. And this is what we have on that L35E. Now remember, the L35E is not what we're working with right now. I'll just spread this out a little bit so you can see more. Wow. That's a long-winded... My goodness. I'd hate to carry around a name like that. So that's what made that output card a P, electronic short circuit protection, P for protection. So remember, that was an OB16P. Now, let's collapse. Well, maybe we won't have to. Yeah, let's collapse that just to get some more space, because I have limited vertical space on the screen here. Now I'm going to plug in the Ethernet cable to the L45 ENBT that we just added. And we'll see if it's friendly today. If it is, and of course, you know, I don't have that address in my Ethernet driver. So I'm going to click up here because you can't edit a driver if it's browsing it. So we'll go to Workstation, so it's not browsing. We'll go to Configure Drivers. We'll go to our Ethernet Yeah, I don't have it in there. Remember, I told you I probably used 99? Well, I lied. So we could have used 99 just like you did in the lab. So we'll just type in 192.168.1.98. And just for grins, we could punch in 99, 97, or we could even use the IP driver. I prefer using the Ethernet devices driver for this situation. So apply, OK, close. Now we'll go down and click on that. Oh, there we go. Popped right in. So we'll collapse this down as well. But I'm going to leave this much in here to show you the difference. Okay? Now, this Ethernet adapter that's part of the L35, it's built right into the processor module and has the port right on the face of the module. It is plugged into the backplane for the Compact Logic system. However, the ENBT is plugged into the backplane of the 1768 bus, so you have to go across the backplane to get to the processor or to get to the MO4SE. So we'll expand out, and there's our I/O modules. Get a little bit more. And then, of course, on the Circos interface, we had the MO4SE, and if I had left the drive plugged in, we could see the drive. So I have Ethernet plugged into both the L35E and the L45. So there's the, see, it doesn't say L45 because that ENBT is not part of the L45. It's a separate module on the 1768 backplane. It's a separate entity, whereas this is not a separate entity. You could say electronically or data-wise it is, but physically it's part of that processor right there, even though it shows the backplane as the connection between the card and the processor. This is all one piece of plastic, so to speak. This is a piece of plastic, and this is a piece of plastic, and this is a piece of plastic. Now, with all of these products, the backplane is not a separate chassis that you slide these components into. The backplane is made up of backplane segments. Each module has a segment of the backplane as part of its construction. And when you assemble these modules together, like the 1769 modules, they slide into, next to an adjoining module, and then there's a little lever on the top and towards the back that you rotate counterclockwise, and that engages a connector into the socket of the adjacent module to the left. With 1768, it engages into the module to the right. So if you want to say 1768 is left wing, and 1769 is right wing. And of course, that depends on whether it's you or the processor, whether it's right or left. If you look at the processor, 1768 is to the left and 69 is to the right. But if you are the processor, then the 1768 is on your right and the 1769 is on your left. So that was an interesting little side trip for you. And now we are connected. If we were to download this, of course, we didn't finish editing tags, and we're not going to. So we have extended now our paths onto the 1768 backplane to include a Circos network. So even though you might say that an MO4SE is a motion module, it's really not. It is a Circos communication adapter or bridge. Actually, it's not a bridge, it's just a communication adapter or Circos interface module. Okay, so we added that. The next thing that we're going to do, and since we're at 23 minutes, I think we'll cap this off and then start another one to add additional things into Ethernet. Now, some of this hardware that we're going to add in the next session we don't actually have. We're just going to show you how to add it and configure it, but we won't be going online with it because we don't actually have that hardware at our disposal. So thank you very much for watching. Welcome back. In this section of the lab, extending your data world onto the highway and into a remote neighborhood. We consider Ethernet as a data highway simply because there are no neighborhoods, only exits and interfaces into neighborhoods. So the neighborhoods are actually data structures where data lives. But Ethernet, IP, DeviceNet, ControlNet, they are all data highways. And they each have their specific characteristics and advantages and disadvantages. And we're not going to talk about the advantages and disadvantages in this presentation. We're just going to go through the lab. So the first thing we had to do was to add a 1794 AENT to your data network. And remember, you're adding this to Ethernet. So we go over here to Ethernet, right click, new module. And of course, we're going to get a whole bunch of stuff. So we're looking for communications devices. So we'll uncheck, click on communications, uncheck, and just pick Allen Bradley. Now, you can see the variety of bulletin numbers: 1715, 3438, 4756, 56, 57, 68, 69, 83, 88. That's the beauty of Ethernet is Ethernet. And these devices don't actually all have to be Ethernet IP. In this case they do, because we're going to do I/O. So we're going to pick a 1794 AENT. So we could have just typed in AENT and see we have quite a few AENTs. We're specifically looking for 1794. So if we expand this out a little bit, then you can see that the R has 2 ports. So if it has R, then there's 2 ports on there. In this case, we're just going to pick something simple that you're more likely to come across, a 1794 AENT. And we'll be real clever and call it my AENT. And we'll give it a fixed ID of 192.168.1.98. Now you're probably saying, whoa there, Mr. Gates, you used 98 in the last lab. Well, I did, because I thought 99 was already used, but then it turned out 99 was not used. So I went back and changed the ENBT to 99 so I could make this match the lab. So my apologies if that gave you a jump. So we give it an IP address, and we could open up RSLogix. Let's bring this all the way up in here so you don't think you're missing anything. We could open up RSLogix in there, go to RSWho, go to Ethernet, and here, see, it's 99 now. Now, if I go to Ethernet, I'm not going to find anything because I don't actually have anything plugged in. In other words, if we had 98, it would be right here. So I don't actually have this AENT, so I can't go look for the version number. But if I did actually have one plugged in and had an IP address set on it, and by the way, all of these Ethernet devices from almost all companies either have switches that you set to the IP. Most likely, though, they're going to have a interface that you go into through your laptop or computer and you set it electronically. Or it has a little display on the front and you step through the parameters and set the IP. Or you use boot P, and boot P sees the MAC ID, and when you see the MAC ID you say, yeah, that's it, and here's the IP address I want that device to have, and then boot P assigns that IP address to that device. There's many ways you can do it. In this case we don't actually have the ANT, so it doesn't matter. So I'm going to close RSLinks, and if I go to change, really there isn't much that I can actually change. 4.1 is, and I don't know what the minor is, we'll leave it at 4.1. I'm going to disable keying. Also, there's something called rack optimization and none. I'll just explain real quickly. Rack optimization, if you select that, and we'll go ahead and select that, it allows you to treat the Ethernet adapter and all of the modules on it as one data structure. Therefore, you minimize the number of connections needed. See, it says rack connection. When it says connection, it's not talking about a cable or an electrical connection. It's talking about an Ethernet communications connection. And all of these processors that we're working with and the bridge cards, the Ethernet bridge cards, they are limited to a specific number of connections. So in many cases you have a budget for Ethernet connections and you want to not waste them by giving everybody out there a connection. Typically a 1756 chassis, each module can have its own connection, or you can rack optimize and it treats the whole chassis as one data structure. So in this case we're just going to keep it simple. Chassis size, we'll just make it 2. You pretty much have to specify this correctly for the number of modules that you want to put in there. Unfortunately, between one Ethernet adapter and another, sometimes the adapter is 0 and the first module is 1. Sometimes the adapter is 1 and the first module is 2. Most of them I think the first module is 1. So we'll just click OK, and then I'll drag this up so you can see OK. OK. Close. And there's our AENT with a flex bus. So now our Ethernet card shows up, and this is the Ethernet cable leaving the ENBT going to the AENT, and then the adapter for Ethernet has a flex bus that uses flex IO, and then to the flex bus we can add modules. And so just for grins we'll add an input card. We'll make it an IB16, and we'll say my remote and this is DCN, and it's in the very first slot. So we'll just leave compatible keying, and then we're going to add another card, and we'll make this another digital card, and we'll make it a output card. So we're looking for an OB16. See, they have a diagnostic output. We'll go fancy with the diagnostic output, and goes in slot 1. Okay, so now we got an input card and an output card in the remote chassis. And I'm going to drag this over a little bit, close that window, and now you see we have remote I/O. So what separates this I/O, this 1794 AENT, and the two I/O cards is the Ethernet cable. And there could be Ethernet switches, hubs, any other type of switching device in between the ENBT and this device. This device could be a couple hundred yards away. So that's how you configure I/O. Now we can go and look at the properties, and of course the RPI is set at 20 milliseconds. I think we pick rack optimize, if I remember correctly. I'm going to go back and look. If we pick rack optimized, then whatever RPI we set here is fixed for the whole bunch. So we'll change that to 40 just for grins. And of course the OK is down at the bottom. And now we'll open that up again. See, now it says 40. So when you rack optimize, every module in that adapter bus on the flex bus is all going to have the RPI that you set for the AENT because you rack optimized. Now if you want individual connections, if you want to burn up your budget of connections, one per each module, you can do that and not select rack optimize. Module info and fault idle conditions. So this is what makes this a diagnostic card. So you can set the safe state value at on or off. So in other words, if the system stops running, you can have a safe state value. So if you had, say, a solenoid valve and you want that solenoid valve to stay energized as a safe state, if the processor stops, then that's what you do with these settings. Okay, that's a little beyond what we did in the lab. We'll maximize that back out. We'll drag this back over so it looks like a real rung again. I don't care to look at this stuff all jammed up like that. I mean, if you got a really big rung that has, 30, 40 instructions in it, it's going to be wrapped all over the place. Believe me, I've seen them. I try to avoid that myself. So we added an AENT to our Ethernet. And then we also added a 1794 IB16 and a 1794 OB16, just like in your lab procedure. Then we spent some time showing what kind of devices that you could have picked off of this AENT. So besides the AENT, so if we go back to Ethernet, new module, you see, if you look at the list here, we showed this list in the lab book, so you could see the many devices that you could pick to hang off of that Ethernet. And of course, you can put quite a few. Okay, we'll close that, and I think we'll just leave the lab finished at that. So save your project. Remember that it was built with a RSLogix with compact I/O 1769, and we will have gone through this procedure of adding I/O several different ways under several different conditions with RSLogix, which is probably next on the list to do something with RSLogix. We've done it with L35E and now L45. So you see the procedure is basically the same. You go to the bus, you go to like the 1769 bus here. If we want to add another module, we just right click and add another module. And then the process is the same. It comes up with a list. You can set the filters and then find your card. Now we're not going to add one because this is what we've got. Now we don't have this Ethernet stuff. So to get rid of it, I'm going to right click, delete, right click, delete, and then right click, delete, and now we're back to just the ENBT and the Ethernet cable. So That's it for this section. And as I said, we'll probably do RSLogix next. Thank you for watching Communication Modules and Remote I/O.